Understanding ANOVA, the key to variance analysis. Hello, dear learners. Today, we're diving into a fascinating topic in the realm of data analysis for GMAT and GRE prep, ANOVA, which stands for Analysis of Variance. If you're preparing for these tests or just curious about hypothesis testing, you're in the right place. Let's get started. ANOVA is a statistical method used to test differences between two or more means. It is especially useful when comparing more than two groups, as it can tell us if the means of these groups are statistically significantly different from one another. Think of it as an extension of the t-test for multiple groups. Imagine you want to compare the average scores of students from 3 different classrooms. Instead of conducting multiple t-tests between each pair of classrooms, you'd use ANOVA to see if there's a significant difference in scores among them. In hypothesis testing, making multiple comparisons, like with multiple t-tests, increases the chance of a type 1 error, falsely concluding there's a difference when there isn't. ANOVA addresses this by assessing all groups simultaneously, reducing this error risk. Moreover, in real-world applications like business, psychology, or education, often we need to compare more than 2 groups. ANOVA provides a holistic view of these groups' performances or outcomes. For ANOVA to give accurate results, certain assumptions need to be met. 1. Independence of observations. Each group's samples must be independent of the other group's samples. 2. Normality. The data in each group should come from a population that follows a normal distribution. 3. Homogeneity of variance. The variance among the groups should be approximately equal. It's crucial to check these assumptions before proceeding with the test. Let's introduce some terms. Between group variance, the variability between the different groups. Are the group means different from one another? Within group variance, the variability within each group. How spread out are individual data points from the mean within their respective groups? The essence of ANOVA is comparing these two types of variances. If the between-group variance is significantly larger than the within-group variance, it suggests that the group means are different. Imagine an experiment where 3 types of diets are tested for weight loss efficiency. After a few months, we collect data on how much weight participants in each diet group have lost. Instead of conducting t-tests between each pair of diet groups, we'd use ANOVA to test if the mean weight loss among the 3 diets is significantly different. If the ANOVA result is significant, it means at least one diet's mean weight loss is different from the others. We could then proceed with post hoc tests to determine exactly which groups are different. ANOVA is a powerful tool in hypothesis testing, especially when comparing multiple groups. By understanding its concepts and applications, you're better equipped to tackle related GMAT and GRE math questions. Remember, statistics isn't just about numbers. It's about understanding the stories they tell. We hope this video has illuminated the story of ANOVA for you. Best of luck with your test preparations and keep learning.